Hey guys, I hope you all had a wonderful spring break. Just a few more weeks of school left. How awesome. And you're almost high schoolers. So exciting. All right, so on today's lesson and this week, actually, you're going to be finding the zeros of a polynomial function. And really what that means is that when you have a function graphed, those zeros are going to be the x-intercepts, okay? So basically, when you're finding the x-intercepts, you're always going to set what equal to 0, y. You're going to set y equal to 0 when you're finding the x-intercepts. And the opposite is true. If I wanted the y-intercept, I would set x equal to 0, right? So last week, you practiced simplifying binomials, right? You thought of two numbers that would add to give me multiply to give me 3 and add to give me 4. Well, you're going to do the same thing today, except we're going to go a little bit farther. So the two numbers that multiply to give me 3 and add to give me 4 are going to be 3 and 1. Now, when you're finding the zeros, anytime you multiply any number by 0, you get 0, right? So if let's say my first number was 0. If I multiply by another number, I'm going to get 0. And the opposite is true. So basically, if this is set equal, if this whole value is 0, it wouldn't matter what this value is because 0 times anything is 0. So if either one of these two parentheses has a value of 0, that means you're going to get 0 as an answer. So basically, you take both sets of parentheses and set them equal to 0, and then you're going to solve for x. For example, if I want to solve for x, I would subtract 3 from both sides. So I would say that x is equal to -3. And then on this one, I would subtract 1 from both sides. So I would say that x is also equal to -1. So you have two values for x. All right, so if x were either -3, and I plugged a -3 into this whole equation, I would get 0. Or if x were -1 and I plugged in for x, I'm going to get 0. So -1 squared is 1. 4 times -1 is -4. So I have 1 minus 4 would be -3, and -3 plus 3 is also equal to 0. Okay, so on almost all of these problems, and sometimes, well, on all these problems, I'm going to have either 2 or 3 answers. So that's the first one. Okay, so just let's do these together. And after we've done a few, you're going to kind of get the hang of it. Okay. All right, so let's look at the second function here. We have 4 terms. So remember how we did that? We're going to group these. And then this first group, I want to think, what can I pull out of both of these terms? What's the greatest common factor? So it's x squared. So x to the third divided by x to the second is x. And x squared divided by x squared is +1. And then here, I'm going to pull out a -1. And then remember how we did this? I'm trying to get the same thing in the second set of parentheses. And -4x divided by -1 is +x. -4 divided by -1 is positive. Oh my goodness. So I should have pulled out a -4, excuse me, not a -1. All right, but anyway, I'm going to get x plus 1 in the parentheses. So then our two groups of the numbers outside the parentheses are one of our binomials, right? X squared minus 4. And then we had the other set was x plus 1. All right, and we're going to set both of these equal to 0. So now this is the difference of perfect squares, right? The difference of squares. So this can still be simplified. So here I'm going to find the square root of x squared, which is x. The square root of 4 is 2. And then one gets a plus and one gets a minus. Well, let me erase this. And now I bring down the third one, right? So now I'm not going to actually have two answers. I'm going to have three answers, because if any of these is equal to 0, the whole expression is equal to 0. So I'm going to let x plus 2 equal 0. I'm going to let x minus 2 equal 0. And then I'm going to let x plus 1 equal 0. And then I have to solve for x 3 times. So I'm going to subtract 2. I would add 2. And I would subtract 1. So x could either be -2 or +2 or -1. Okay? So if x, back in my original expression, my polynomial, if I plugged in any 3 of these for x, I'm going to get a value of 0. So here, remember the first one we got 2 answers. Our largest exponent is 2. And here we got 3 answers. So that leading exponent and that the leading exponent should match how many answers you get. Okay. All right, so let's look at this one over here. The first thing I'm going to do is say, well, both of these are divisible by x, right? So the first thing I'm going to do is pull out an x, and then I get x squared minus 4. Well, once again, we have the difference of squares. So I can simplify this, finding the square root of x squared, the square root of 4, and then one gets a plus and one gets a minus. And then I bring that x down. I forgot to set it equal to 0, but I'm going to. So now if this number right here was 0, 0 times anything is 0. So one of my values for x is 0. If x is 0, the whole thing is equal to 0. And then I'm going to use x plus 2 equals 0, and also x minus 2 equals 0. And when I solve for x, I'm going to say that x could equal either 0, -2, or +2. I got 3 answers, right? And I have a leading exponent of 3. All righty, let's look at this one. Now, anytime you have quadratics, which is when your x is squared, you have to let it equal 0, which means I want to get this 4 on the right side of the equal sign, because I want this whole thing to equal 0, because that's what it tells me. I'm finding the zeros of these polynomials. So 4 minus 4 is 0. And then I'll bring down 3x squared minus 11x minus 4. All right, so now my leading coefficient isn't 1, it's a 3. So then I'm going to do my AC method. Remember where we multiply a times c, and I got -12. So 2 numbers that multiply give me -12 and add to give me the middle term of -11. So those would be -12 and 1, right? So then I'm going to rewrite this so that it's got 4 terms. So I'm going to bring down my first term. I'm going to rewrite my second term to be -12x plus 1x minus 4. So now I have 4 terms, so I'm going to group them. And then I want to see what these first two, what's the greatest common factor? So it would be 3x. So 3x squared divided by 3x is x. -12x divided by 3x is -4. And then these already match, don't they? So I would just factor out a 1, a positive 1, and I would get x minus 4. So now my two binomials are 3x plus 1 and x minus 4 equals 0. All of those equal 0. So then I'm going to take 3x plus 1 and set it equal to 0, and then x minus 4 and set it equal to 0. All right, solve for 0. I'm going to subtract 1 from both sides, and then I divide by 3, right? So those 3's cancel. So I end up with x is equal to -1/3. And then when I add 4 to both sides on this one, I also get +4. So those are my two answers, and it makes sense that I got 2 answers because my leading exponent was a 2. My degree is a 2, I guess I could say. All right, now this one is already set equal to 0. I'm going to end up with 2 answers, right? This is not a 1, so I'm going to do the AC method where I multiply 2 times 5, and I get 10. So I need 2 numbers that multiply, give me 10, and add to give me 11. So those 2 numbers are 10 and 1. So I'm going to say 2d squared plus 10d plus 1d plus 5 equals 0. And then I'm going to group. So my greatest common factor is 2d. So I get d plus 5, which matches this one, doesn't it? So I'm going to factor out a 1, and I get d plus 5. So then my 2 binomials are 2d plus 1 and d plus 5 equals 0. So I'm going to set 2d plus 1 equal to 0 and d plus 5 equals 0. So to solve for d, I'm going to subtract 1. So I have 2d equals negative 1. Then I divide by 2. So one of my answers is negative 1/2. And my other answer is negative 5. So if these variables, either one of them was equal to either negative 1/2 or negative 5, I'm going to get 0 as an answer. You can always plug in and check to see if that's true. All right, so then we're going to practice not only graphing quadratics, but we're also going to graph cubic functions, which has a little 3, right? So quadratics has a 2, and cubic functions has an exponent of 3. All right, so when I look at these, I kind of think of a smiley face or a frowny face, okay? So what makes this open up to be a smiley face and what makes this open down to be a frowny face depends on the leading coefficient. So if the leading coefficient is a positive 1 or positive anything, it doesn't matter. If the leading coefficient, so this is a positive 1, if it's a positive any number, it's always going to, a quadratic is always going to form this shape right here, which is called a parabola. Parabola. It's not parabola, it's parabola. And it's going to be a happy parabola. It's going to be a smiley, an open up parabola. Okay, it's the leading coefficient that determines that. If it's positive, even if all the other numbers are negative, if the leading coefficient is positive, we have a happy parabola. If the leading coefficient is negative, whether it be a -1 or a -5 or a -1/3, it's going to make a parabola that opens down, okay? So if it's a quadratic, which means the largest degree is, a 2, it always makes a parabola, always, always, always. And parabolas are very symmetrical. But if you have a function that has the exponent of 3, you're going to get this funky little design, okay? Both of these will form, these are what cubic functions look like. Now, if you notice here, the bend, it can be small or it can be large, like this one is a lot bigger, right? Now, the leading coefficient, so remember how positive slopes go up and negative slopes go down. So the leading coefficient of a quadratic, so something like that, I just made that up. If the leading coefficient is positive, the beginning part of your function is going to go up and to the right. Okay, notice this one, I left the function. You notice it's a negative number. The leading coefficient is always going to start with it going down and to the right. Okay, so however it begins, it ends the opposite way. Okay, so this, I'm sorry, I said that backwards. It begins and ends in the same direction. So this starts going down when it opens, and when it ends, it's going to end the same direction. Okay, this starts by going up and to the right. It also ends by going up and to the right. And then we have that funky curve in the middle of cubic functions. So those are always you're going to always see the same pattern, and it all depends on the leading coefficient. If this is positive, it starts positive and it ends positive. This is a negative leading coefficient down here. It starts and ends going down and to the right. And you're going to have questions about that. So I'm just trying to explain it to you. All right, so we're going to start graphing quadratics. Now, cubic functions are a little bit more complicated, but we can estimate what cubic functions look like. But for quadratics with an exponent of 2, we know exactly what they look like, because using the formula, we can find all of these things rather quickly. We can find the x-intercepts. Where does our quadratic cross the x-axis? Or if it does at all, sometimes you have one above or below the x-axis, and we'll talk about that in our next unit. Did I tell you earlier this is the last unit? I think I said that. Now that I'm remembering, I think I said that. It's not true. We have one more unit. All right, anyway, we can find rather quickly the x-intercepts, the vertex, 2 other points besides the vertex, and the x-intercepts, and the line of symmetry, because I told you parabolas are symmetrical. In other words, if you bend them in the middle, they're going to lay on top of each other. The 2 sides are going to lay on top of each other. All right, so the first thing you're going to do to find the x-intercepts is you're going to set y equal to 0. So imagine that this is an equation. We're going to let it equal y. So to find the x-intercepts, we set y equals 0. So that's what we were just doing, right? We were solving quadratics. We were finding the zeros. That just means set it equal to 0. So now I'm going to figure out 2 numbers that multiply to give me 12 and add to give me negative 8, right? So those will be negative 6 and negative 2. Because negative 6 times negative 2 is positive 12, and negative 6 plus negative 2 is negative 8. So once again, we set both of these equal to 0. So if I add 6, and here I would add 2. So x is 6 and 2. So these are the x-intercepts. So on the x-axis, I'm going to put a dot at 2, 0. And 6, 0. So our x-intercepts are 6, y is 0. The other x is 2, y is 0. Okay? All right. Let me get rid of all this stuff so I can do the vertex. Now you're going to have to remember a formula to find the vertex. So basically, remember earlier when I told you what they look like when we graph them? They're either going to be a happy parabola or a sad parabola. This leading coefficient is positive 1. So this one is going to go up and, up. It's going to open up like a smiley face. And we know that it's going to cross the x-axis here. So basically my vertex is going to be down here somewhere. So if you have a happy parabola, you're going to have a minimum value, which is going to always be the vertex. And then these lines will go up forever in both directions. If you have a sad parabola, these are going to go down in both directions forever. So that means you're going to have a maximum. Here, you're going to have a minimum. You're going to have a bottom when it's happy, and when it's sad, you're going to have a top. And the other 2 values go down forever. So to find the vertex, so you're going to need to write these in your notes. You're going to write, so vertex. Also, we could call this the maximum or minimum. Okay, go ahead and write this down. It'll come back to us later. And this is how you find it. You're going to use negative b over 2a. That's the x value. Okay, so our leading coefficient is A. So this is always going to be A, the leading coefficient. The number multiplied by x to the first power is B. And your constant is always letter C. And we'll use C later. Right now we're using only A and B. All right, so I'm going to use the opposite of B. So B is -8. So A is 1 and B is -8. So when I do the opposite of B, I'm going to plug in +8 over 2 times A, which is 1. So 8 over 2 is 4. Okay, so 8 over 2 is 4. Now, when I find the vertex, I need 2 numbers. So basically, that formula right here, this is what x equals. X is equal to -b over 2a. So the x value of the vertex is equal to -b over 2a. So the way I get y is I plug in this value for the whole formula to figure out what y is when x is 4. Okay, so once you use the formula, this is the x value. So in your notes, right, this is the x value. And then you're going to say plug into formula for y value. Okay. All right, let me get rid of all this. I know my x-intercepts were 2 and 6, right? 2 and 6. I know my x value of my vertex is +2. And now to find out my y value, I'm going to plug in 2 for x. 2 squared minus 8 times 2 plus 12, right? 2 squared is 4 minus 16 plus 12. So I know that 4 plus 12 is 16. So 16 minus 16 is 0, which is not right. Was it 2 earlier for our x-intercepts? -12 plus 12 is, that's not right. That can't be right. Oh, it's not 2, guys. It's 4. You're probably yelling that at me, right? 8 divided by 2 is 4. Okay, I knew that wasn't right. I apologize. I would start my video all over, but then I'd have to re-say everything I've already said, and I don't want to. All right, so I apologize. See, I erased it, and I forgot what my answer was. I'm sorry. All right, so 4 squared is 16 minus 32 plus 12. Well, 16 plus 12 is 28. So that would be what? -4? Is that right? Tell me if I'm wrong. Talk loud so I can hear you. I don't trust my own brain right now because I just messed that all up. 16 minus 32 plus 12 is -4. Okay, I got it right. All right, so now my vertex is 4, and we found that by finding opposite of b over 2a, right? And then my y value is what we got when we plugged in 4 into my whole equation. All right, so let's write down what, oh, I did it again. What's wrong with me? So let's write down all of the points we've already found by what we've done so far. So we found out that the vertex is 4, -4. We found out that one of the x-intercepts is 2, 0, and the other one is 6, 0, right? So then look what this says. It says find 2 other points besides these 2 other coordinates. We'll see how I wrote them. There's clearly numbers between 2 and 4 and 4 and 6. So let's use 3 and 5. All right, and remember I told you parabolas are symmetrical. So Since these are the same distance from the vertex, what should happen is we should get the same y value for both of these. So let's see what happens. So if x is -3, I'm going to plug in -3 squared minus 8 times -3 plus 12. So I know that's 9. And 9 plus 24 plus 12 is 45. Oh, that can't be right. Oh, it's positive. I'm such a dork, you guys. Oh, my word. Positive 3. So I'd have 9 minus 24 plus 12 is -3. Okay. And then let's go ahead and plug in positive 5. So positive 5 squared is 25 minus 40 plus 12. And I got -3. 25 minus 40 plus 12 is -3. So like I said, they should be symmetrical, and I'm going to see that they are. All right, so let's graph all these points. So I have 2, 0. I have 3, -1, 2, 3. And I have 4, -4, 1, 2, 3, 4. And I have 5, -3, 1, 2, 3, and I have 6, 0. So look what happens when I connect all these dots. I get a happy parabola, right? And I told you that these are very symmetrical. If I drew them perfectly and I bent it in the middle, they'd lay on top of each other. So we always have this thing called the line of symmetry. So whatever the x value is, it agrees with our line of symmetry. So that's where I would fold it. And so this is a vertical line, right? A vertical line is always going to be your line of symmetry. And remember how we write vertical line equations, Buck's vertical lines? Only an x is in the equation, and that is always going to be the x value of your vertex, which is 4. See, this is x equals 4 right there. This is our line of symmetry, okay? All right, now this is gonna be a long video, so I'm gonna go ahead and stop it, and then I'm gonna make you guys another video to do the rest of the problems, okay? So you're gonna end up hopefully having 2 and watch both of them, because these are confusing once you do only 1 or 2, but once you do more than that, you're gonna find the pattern very consistent. All right. See you in a few minutes.